Good morning, everyone. Good morning. Hope all is well. Hope everyone is doing all right. All right. So looks like
Morning.
good morning, sir. Good morning. Looks like everybody is in. Before I do anything, did anybody have any questions, concerns, anything before we get rolling? Is everybody good? Mm, 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 that's that. So we're gonna do complex fractions. Ain't we in here last class. I think that's the last section for this one. Let me check to make sure. Sorry for running late. I got caught up in traffic. So last class we solved equations. Okay, so we just got 14.7. That'd be it for chapter 14. So we can just do that one section today. We don't have to push it, but this is our last section in section 14, 14.7, complex fractions. All right, so there are two different ways you can do it. Well, let me say it like this. Complex fractions are fractions that is more than just one fraction. So in other words, when I look at fractions, this is a fraction 4w squared over 5r. S is one fraction. So now that's one fraction. This is two fractions, and all together they make up one whole fraction. So really you have three fractions. So that's what makes it complex. So whenever you have more than just this, it's considered a complex fraction. So we can simplify this one of two ways. So we'll look at method one and then look at method two. Now, method one is only an option if you have one solid fraction over another solid fraction. So in other words, let's see, like this one. Notice I have this, 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 this. So I have four different things going on. So it would be more beneficial to start off with method two. So going back here, we have one solid fraction over another solid fraction. Then that's when method one would be beneficial for you. Method two, you can use no matter what is going on. So just throwing it out there. So, but just like to explore all options, show you all options. When I look at this division sign, that is this division sign. So I went from writing my fraction vertical, now I wrote it horizontal. So that's all we did. We haven't changed anything. Just went from writing it vertical to writing it horizontal. All right. Then from there, don't forget whenever you divide it by a fraction, you're going to multiply by the reciprocal. So your division changes to multiplication, and then you flip this fraction. So whenever you're dividing by a fraction, you multiply by the reciprocal. Excuse me, had to sneeze. All right, so once you have changed the division to multiplication and you flip your fraction, now you can reduce by canceling out. So let me erase this stuff. So you have 4w and 4 and 2 w's, 5rs. So that's what we have here. All right. So I just expanded it out. Then we have two s's, s squared. And the 20 I wrote is 4 times 5. Then that's WR. And the reason why I wrote it as 4 times 5 is because I have a 4 right here that can cancel out. So now you cancel out with what you have in common with the top and bottom. So 4's cancel, as I mentioned before. I have one W that will cancel. And then I have an S that will cancel. So what you have left on top is W and S. And down bottom, we have 5, R, and 5. So you multiply those together, and we get WS over 25 R squared. All right. Questions on that one before we do another one? So basically all we're doing is simplifying these complex fractions. All right, let's scroll up. All right, next one, same type of deal. I'm going to use method 1. We have one solid fraction over another solid fraction. Y minus 8 over 5y over 3y minus 24 over 15. So once again, we're going to go from having written it vertically to write it horizontally. So this divisional bar is the same thing as this divisional symbol. So I haven't changed anything yet. Once again, all I did was rewrote it. And so now that division sign changes the multiplication, and then you flip the fraction that follows. So that's what happened in both of these cases. So before we go any further, make sure we're okay with that. Everybody good? All right, so let me erase this. So just like before, factored and broke down what we had. Y minus 8 is nothing you could do with that. 5y, nothing you could really do with that. But then 15, I can break that up into 3 times 5. And then that 3y minus 24, I pulled 3 out of that, leaving me with y minus 8 in the parentheses.
Hey, Mr. Tucker.
Yes, sir.
Good morning.
Good morning.
For that 15, when you drag that 3y over 3y minus 24 over 15, you dragged it down and it flipped over, right?
Mm-hmm.
To the 15 over the top. Okay.
Mm-hmm. Yeah. And the only reason that happened is because it follows the divisional sign. Yeah.
That last part got me confused. You
Right here?
You said follows the division sign?
Yeah, whenever you divide it by a fraction, let's say if I had 1 over 2 divided by 3 over 4. Yeah, it's that same thought process. Division change the multiplication, and then you flip the fraction that follows.
Okay.
Yep.
Thank you.
Oh yeah, not a problem. All right, so now we can cancel out y minus 8. Cancel out this 3. Cancel out this 5. And you know, if let me see, I got orange. I can do red. So this y whole thing, this whole y minus 8 cancels. So if that's the case, then the only thing that's left is 1 here. This whole thing cancels. The only thing that's left is 1 here. So we have 1 up top and then down bottom. The only thing that's really left is just y. So that's why we have 1 over y. Any questions? All right, can we scroll up, explore method 2? All right, so here we have b over a plus 7b over b plus 2b over a. All right. Once again, we have b over a plus 7b over b plus 2b over a. And let me see. First step shouldn't be multiply. It should be find the LCD. And step 2. So then down here, step 3. So, all right. So first thing we'll do is find the LCD. The only denominator that we have is a. So our LCD, is going to be a for us. And then step 2, and this is similar to the process that we had before when we had fractions and we want to clear out our fractions. And we're going to multiply each numerator. Once again, making sure we hold true to the idea that we multiply each numerator by the LCD. So we're going to multiply each by a. And so that's what we have right here. Any questions before we go any further? We multiply each numerator by a. So that's why we have ab over a. Before all we had was b over a. So now we have ab over a. We have 7ab. Then we have ab and then 2ab over a. Now, step 3 is to simplify. A's cancel here. A's cancel here. Wonder why I wrote that go like that. That'll be b plus 7ab. So we got b plus 7ab over ab plus 2b. I'm try to take it down here. So then the next step is to factor if possible. So we're going to factor out b from each term. So factoring out b from the numerator, because each one of them have b involved. So that'll be b times 1 plus 7a. In the denominator, factor out b, that's b times a plus 2. All right, so b's cancel. And that'll leave you with 7a plus 1, a plus 2. Questions? Any questions? All right, let's try it again. All right, so this next one is the original problem right here. 8 over x squared plus 1 over x over 2 over x squared minus 1 over x. So we hold true to the steps that we just finished executing. The first step is to find your LCD. So we have x squared and x in either one of the LCD, either one of the denominators. So highest power of x is 2. So that will be our LCD, x squared. So we're going to multiply each numerator, just the numerators, by x squared. And that's what happened here. So you have 8x squared over x squared plus x squared over x over 2x squared over x squared minus x squared over x. So in the first one, x squared, the whole x squared will cancel. In the second one, x, only one of the x's will cancel. So that'll leave you with one of those x's. Down bottom, all of x squared will cancel. And then one of the x's will cancel once again. And that'll just be 8 plus x over 2 minus x. Questions? Any questions? All right. Try it again. All right, so this is the original problem. N to the negative second power minus m to the negative second power over m to the negative first power plus n to the negative first power. All right, so rewriting it, is what we did here. So don't forget, whenever you have a negative exponent, to make it positive, you drop it down into your denominator, or turn it to a fraction. So that's what ended up happening. This, we want to color code it. This is this. This is this. This one is this, and then this one is this. So, just rewriting it as fractions to get rid of those negative exponents. Any problems with the rewriting before we go to the next step? All right, so find the LCD. So notice we have m and n involved in both. When each one of the denominators is m and n, but we have the highest power of both m and n is squared. So that's why the LCD is going to be m squared, n squared. So you always take the highest power of those letters that you see, just like we did x, we had x squared and x. So we chose x squared. Here we have m, n, m squared, and n squared. So you choose m squared, n squared. And then you multiply each numerator by m squared, n squared. And this is what we have. M squared, n squared over n squared minus m squared, n squared over m squared. Then m squared, n squared over m plus m squared, n squared over n. Any problems, any problems? All right, so now we can cancel out. N squared cancels here. M squared cancels here. Down bottom, we have one of the m's that will cancel. Still leaves you with this m here though. Same thing here, one of the n's will cancel. Still leaves you with n. So these are things that are left. So we have m squared minus n squared over mn squared plus m squared n. So with m squared minus n squared, that's a difference of squares. And then we can factor out mn in that denominator. So it will look like this. M plus n, m minus n in the numerator. And if I were to pull m and n out of each one of those terms in the denominator, that would leave you with m plus n plus m in that denominator in the parentheses. All right, questions. All right, so cancel out common quantity of m plus n. And we're left with m minus n over mn. Questions? Any questions? All right, I think we got at least one more. Are we okay with this one before I scroll up? All right, next one. Let's see, are there any more? Oh, two more. Yeah, that was something else. Just checking to see how much we got going on right here. So that's an old one. Yeah, that's not it. Good. So we got these two. Okay. All right, just seeing what I had left up here. So 1 minus 1 over x minus 6 over x squared over 1 minus 10 over x plus 21 over x squared. All right, so once again, establish where your LCD is. So LCD will be x squared. We have x and x squared as our denominators. Highest power of x will always be what your, or highest power of your variable will always be what you use as your LCD. So we're going to multiply each numerator by x squared. And that is what happens here. Yeah, x squared minus x squared over x minus 6x squared over x squared minus 10x squared over x plus 21x squared over x squared. So cancel out where you can. X cancels here, just and it leaves one of the x's just like before. X squared cancels completely here. X squared cancels completely here. One of the x's cancel here. Still leave you with one of the x's. So this is that result. X squared minus x minus 6 over x squared minus 10x plus 21. All right. Any problems? Now we can factor out each trinomial. So x squared minus x minus 6 over x squared minus 10x plus 21. That'll be x minus 3, x plus 2 over x minus 7, x minus 3. X minus 3's cancel, leaving you with x plus 2 over x minus 7. Any questions? All right, so we got at least one more here, unless you guys want another one. All right, so we have 11 over x plus 10 over x plus 1, 10 over x minus 11 over x plus 1. LCD is just a combination of both of our different denominators, x and x plus 1. And once again, we're going to multiply each numerator by the LCD. So that's what we have here. 11 times x times x plus 1 over x plus 10 times x plus 1 over x plus 1 over 10 times x plus 1 over x minus 11 times x plus 1 over x plus 1. All right, so cancel what's in common. First one, we have x. Second one, we have x plus 1. This third one, we have x. Last one, we have x plus 1. So that leaves us with this result. 11 times x plus 1 plus 10x over 10 times x plus 1 minus 11x. Now distribute where possible. So that'll be 11x plus 11 plus 10x. And then in your denominator, 10x plus 10 minus 11x. All right. Combine your like terms. So in our numerator, 11x plus 10x is 21x. In the denominator, 10x minus 11x is negative 1x. So we give us 21x plus 11 over 10 minus x. Questions on anything? All right. All right, can I go to another page? Very good. All right. All right, so just reviewing where we are in the class. So we just knocked out the rest of chapter 14. So of course, at the end of the chapter, you have that test. So now we're looking at some point starting chapter 17 and eventually getting out to 18, and then that'll be it as far as our new material. So we'll see how that goes as far as timing and stuff is concerned. But just let you know, give you a heads up as to what is left. So don't forget, when it comes to your scores, your test scores, and your homework scores, you are expected to get at least a 75 on everything. And if I'm not mistaken, the homework is supposed to be 80, but I think I said 75 in the beginning. I think I was supposed to say 80 for homework and 75 for your test. But since I said 75 in the beginning, so we just talking about 75 for everything. And so just make sure we try to hold true to that. Any questions on that? Any questions on anything? Okay. Somebody said something in chat. Yep. So if you're gonna come next class, well, not next class, if you come tomorrow, 24 office hours to take that test, just make sure if you're coming to take a test that you come no later than 9:30. So in between that 9 to 9:30 gap to make sure you have enough time to take your test. Yep, not a problem. So 9 o'clock is the time for test taking tomorrow. All right, so you come enable your camera. Let me know which one you're trying to take, and then I'll give you the password for that. All right, and also let me know if you're taking it for a second time because I have to go in there and make an adjustment. So you gotta let me know that too as well. All right, anything else? Anybody else before we close today? All right, good. Oh, check. Mr. Davis' email is jldavis@tcc.edu. So let's put it in chat, jldavis@tcc.edu. Yep, not a problem. Anything else, anybody else before we close? All right. Well, you guys have a good one. Be safe. Have a great weekend. And I will see you next class.
All right, now, Mr. Tucker, take it easy.
I appreciate it. You do the same.
Have a great weekend.
Thanks. You do the same, sir.